When we're dealing with improper integrals, we have to first of all recognize when they're improper. And improper, by definition, are unbounded integrals. So these are integrals that go to infinity, so like this one here, or integrals that go up along asymptotes. Those are improper integrals. When we have those, we have to use a limit notation. So here I have this function, e to the negative x. So if I can imagine what that looks like, that is a negative exponent. So that means that it is an exponential decay curve, something like that. And I want to integrate this from 2 from 2. So I'm going to mark that boundary 2 to infinity. So it's going to go out like that. Okay, so it's going to be that area in there. So recognizing that it is an improper integral because there's a infinity in there, I'm going to apply my limit notation. So my area is going to be equal to, I need to use a limit. I'm going to use a variable t here as t goes to infinity, and I'm just going to replace that infinity with a t. And that's from that's e to the negative x times dx. Okay, so I have that. All I need to do then is just do this all properly without while keeping the limit notation. So I'm just going to make sure I keep the limit notation. T goes to infinity. And then I'm going to integrate e. So this becomes negative e to the negative x. And then my bounds are where my limit is. So 2 to t. Okay, so then I'm going to then plug in my bounds. Since I haven't replaced t with infinity yet, I'm just going to write like this, negative e to the negative t minus negative, so I'm going to go plus e to the negative 2. Okay, so that represents my area. At this point, I can plug in my infinity. So I'm going to evaluate this as negative e to the negative infinity plus 1 over e squared. Now, e to the negative infinity is 0, so then this becomes, the area is going to be 0 minus plus 1 over e squared. So what that tells me then is this area that's unbounded with along the x-axis, this area works out to be 1 over e squared, so about 0.1, somewhere around there. This next one, b, this is an unbounded integral as well. Now it's hard to recognize unless you remember that, well, there's a vertical asymptote at x equals negative 1. Okay, that's what makes the denominator equal to 0. And it also happens that I am integrating up to the asymptote at negative 1. So this means I need an improper integral. I need to use a limit when I'm doing this. So the graph looks like this. From negative 1 to 5, that area that I'm going to look for, well, I'm going to take this area up to 5 here. And from negative 1, which is unbounded, this is the area that I'm going to calculate here. So I have to use a limit along that edge. Okay? So the limit is really a formal way to do this, but it is something that to do this properly, we need to use that limit notation. It doesn't actually affect our calculation though. So I'm going to now use a limit. I'm going to use a variable t. Sometimes we use different variables. And I'm going to approach negative 1, but I'm approaching it from this side, so it has to be from the positive side. And then my limit is going to be from t to 5. It's going to be 1 over the cube root of x plus 1 dx. So the limit as t approaches -1 from the positive side, the antiderivative function, so if I find the integral of this, I'm going to use power rule. So it goes from power 1/3 to power 2/3. So I'm just going to write this out, x plus 1. So the negative 1/3 becomes positive 2/3. And I have to divide by 2/3. So I'm going to multiply by the reciprocal of 3 over 2. And then make sure you keep track of your bounds from -1, which is t, to 5. So I can plug this in. The limit as t approaches -1 from the positive side, I have 3 over 2, and I'm going to plug in the x, so I'm going to end up with 6 to the power 2 over 3 minus, when I plug in the -1 into here, I'm going to end up with my power 2 over 3, but replacing x with -1, this ends up being 0. Okay, so that -1 plus 1 is 0. At this point, I've plugged in, actually, maybe I still have my limit notation, so I'm just going to write it like this, -1 plus 1, or sorry, my t plus 1 to the 2 over 3, and then I'm going to plug in my limit. So I end up with 3 over 2, my 6 to the 2/3, minus, that becomes 0 to the power 2/3. So this works out to be 3 over 2, and it's going to be the cube root of 6 squared, or 36. Okay, so this represents that area under the curve is going to be 3 over 2, the cube root of 36.